Okay, our simple PCB is finished, but before we generate the documentation for manufacturing for this PCB, let's make it a little bit more complicated. I would like to speak about few things which you may find very useful and which are very often happen when you are doing PCB layout. So, for example, what can happen? You may be doing the layout and suddenly you find out you need to make some changes in the schematic. So how to do it? Yeah, how to make changes in the schematic when you have already started doing layout? It's very simple. Just go into your schematic, left click here. Let's say we would like to add one more LED and one more resistor. So I'm going to copy this. Press the left button on your mouse, hold it down. Release the left button. Control C, Control V. Place it maybe like here, left click. Connect this resistor, left click on this place wire button, left click, left click, left click, and connect this LED. Left click, left click, left click, right click. We need to do one more thing. What is wrong in this schematic, do you know? These two nets, they have exactly same name. So basically, they are connected together. We don't want to have them connected together, so we need to change the names of these nets. Left click on this first one, and here in this properties panel, just call it diode 1, enter. Left click on this one, and left click here, call it diode 2, enter. We need to annotate the schematic because here is question mark and here is question mark. We would like to replace it with numbers. Left click on tools, select annotation, left click on annotate schematic. Here you can see the D question mark and R question mark. Left click on update changes. We are going to update two components. Left click on OK. Now Altium is suggesting to name this second diode to D2 and this second resistor to R2, so that's perfect. Left click on accept changes, and now Altium is going to rename the components. So left click on execute changes, left click on close, and left click on close. R2, D2, everything what we have to do to transfer these changes into our PCB, just left click on design and left click on update PCB document. Here you can see what is going to happen. Yeah, we are going to add two new components. We are going to connect them to these two nets, and diode net is going to be renamed and the new diode 2 net is going to be added. That's exactly what we would like to do. Again, left click on execute changes. Watch this, okay? All these, they need to be green. If you see some red cross here, it means there is error, there is a problem. So you need to then check your schematic or libraries. Now, here everything is green, so that's okay. Left click, close, and here we have the new components, and we are going to place them into our PCB. We could place these components manually, just press left button, hold it down and move it on the PCB, but very often you are not going to do it this way. Very often when you are placing components, you would like to place them based on schematic. To see the schematic and the PCB in one view, just right click on this PCB tab and left click on split vertical. If you have two monitors, you can simply just drag and drop this on second monitor, and then you will have schematic in one monitor and the PCB in the second monitor, but I cannot use it, I have to do it this way. Then what you need to do, left click into PCB, left click on tools, and be sure that this cross select mode is enabled. I will explain what it does. Just be sure around this icon there is a frame. When I press the left button, when I press left click on this cross select mode, watch what is going to happen around this icon. Just left click on tools. See, now this means this cross select mode is enabled. Left click into schematic, left click into tools, and double check that cross select mode is also enabled here. Yeah, so that's correct. Now when you enable this cross select mode, what is going to happen is that if you go into schematic, left click into schematic, and when you select something, like for example this component, just left click here, it will be automatically selected also in the PCB. If you select something in the PCB, for example left click on this D2, it will be selected also in the schematic. You can select also a pin. Yeah, left click on a pin, and then this pin is selected. Left click on this component, or like this, it will be selected. The really good feature is that you can select more components like this. We are going to select this R2, just press left click on your mouse, then press shift, hold it down, and left click also on this diode to select the resistor and the diode. Then left click into PCB, don't forget, this is important, okay? Left click into PCB, left click on tools, select component placement, and left click on this reposition selected components. Now what is going to happen, the first component which you selected here in the schematic is going to be picked up, and you can place it on your PCB. Yeah, and then once you place it, press left click somewhere. The second component which you selected in the schematic is going to be picked up, and you can place it in your PCB. This is very useful. It can help you a lot, and it can speed up the placement process based on the schematic. Just left click. We don't want to place them this way. I'm going to use Ctrl Z because I would like to show you something else. You can not only select components between schematic and the PCB, you can use also different command to see specific objects in schematic and the PCB. And this special command is inside of this tools menu. So just left click into schematic, left click on tools, and this is the command cross probe. Left click on the cross probe. Let's say we would like to see where this pin 1 of J1 connector is located. Left click on pin 1 and watch what is going to happen in PCB. Okay. Right click to cancel this command in the schematic. Left click into PCB and zoom out. Here you can see the pin 1 of this J1 connector. All these other objects, they are masked. You cannot work with them. Yeah? You cannot do anything with masked objects. You only can work with this unmasked object. If you would like to unmask the board, left click on this PCB panel, PCB tab, go to this PCB panel, and left click on this clear button. This is very important button, okay? If something is not working in your PCB, it may be because some components are masked or some filters are active. So if something doesn't work in the PCB, if you cannot move component or connect somewhere something, just go into PCB panel and use this clear button, left click here. Also, what sometimes you may want to check, if you cannot work with some objects, check this filter which is here in the properties panel. At this moment, all the objects are enabled, so I can work with all the objects, yeah? But if I press left click on this button, all the objects are disabled. It means I cannot work with anything. And here you can select specific objects what you would like to work with. For example, with tracks. Left click here, you can work with tracks, but you cannot work with components or designators or the other text. If I unselect the tracks, left click here, and if I select vias, so left click here, I can work with vias, left click and escape, but I cannot work with text, I cannot work with components. So if something doesn't work here, check this check this filter which is here and be sure you left click on all objects, and also left click on this clear filter which is here. Then you should be able to work with all the objects in your PCB. Now, very important question. What do you think how this filter can be useful? For example, let's say you would like to delete all the tracks and all the vias on your PCB. You can simply press left click on all objects, left click on tracks, left click on vias. Now press left button, hold it down. Try to select all your PCB, but only what will be selected are the tracks and the vias. All the other objects there will not be selected. Now you can simply press delete on your keyboard and that's it. Yeah, I'm sure you got the idea. Go back and left click to enable all the objects. Left click on schematic, and we are going to have a look what will happen when we use cross probe on a net. Left click on tools, left click on cross probe, and left click on a net. Watch what is going to happen in the PCB, how the zoom is going to change. Yeah? So left click on a net. Right click to cancel this command. We don't want to use this auto zoom. When this auto zoom is enabled, it means all these objects which are connected to the net where we clicked, they will be zoomed in or zoomed out. We don't want to use it. Very often I just would like to keep the zoom on the area where I was before. So to disable this auto zoom, just left click on this navigator tab, right click somewhere here into this navigator panel, and uncheck this zoom on objects. At this moment it is checked. Just left click on zoom on objects. Okay, now when I use left click in this PCB, left click on view, left click on fit board, left click on PCB, clear the filter, left click on this clear button, left click on schematic, left click on tools, and left click on cross probe. Now watch what is going to happen in the PCB when I use left click on this net. Perfect. This is exactly what I would like to have. Right click to cancel this command. And now we can see where the plus 3v3 net is connected. We can see all these pins and we can see all the tracks. We can use this information to place components. Now, I need to say this is not the best schematic to explain what I'm going to try to explain, but I receive many emails where people ask me how to do it, because in the old Altium Designer it used to work differently. This technique, what I'm going to show you, it used to work differently. And this technique is very often to use place decoupling capacitors under BGA, or for example decoupling capacitors around chips. In this technique, we would like to highlight, we would like to see the power pins, and then we would like to select the decoupling capacitors and nicely place them close to these power pins. So we would like to use something like this. We would like to unhighlight only the pins which are connected to power plus 3v3, and now we would like to select the decoupling capacitors which we don't have. In this case we can use just this R2, so we would like to select R2 and place it close to this pin number 1 of J1 connector. And this is what very often happen. This is what will happen in the new Altium Designer, and this is where people have problems. Okay, when I try to left click on this R2 resistor to select it, watch the PCB. Left click here and everything is gone. Everything is unmasked. Now we cannot see where the power pins are located. We don't want to unmask everything. We would like to still have only unmask the power pins. So how to do it? This is how to do it, how you can do it. Left click into schematic, left click on tools, left click on cross probe, left click on the PowerNet plus 3v3, right click to cancel this command, and this is the magic. You need to use shift. So press shift on your keyboard, hold it down, and then left click on R2. See, this is still unmasked, everything else is masked. If I go into PCB, just left click here, zoom out, the R2 resistor is selected, and what we can do now, we can just use the placement command. Left click on tools, select component placement, left click on reposition selected components. So if you have more decoupling capacitors, you will nicely pick them up. So left click on this. In our case, we only have this R2 resistor. And you can also very nicely see how you need to rotate it. Yeah, you can see how you need to place the component close to this pin. In our PCB, we would like to place it on the bottom. So press L on your keyboard to move this component on the bottom side of the PCB. Again, press L. And press spacebar to rotate. We would like to place it maybe like this, left click. Only what is missing to place is the D2 component. We can directly place it in the PCB. So just zoom out. To be able to work with D2, we need to unmask the PCB. So left click on this clear button. And because this clear button is very often used, I will also show you how you can place it on this active bar. First, just place this D2. Left click on this clear button. Left click into PCB. Then press left button, hold it down. Move D2, press L, move it on the bottom layer. Press spacebar to rotate, 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 and place it maybe like this. Release the left button. So very quickly, if you would like to place this clear button on this active bar, for example, we would like to have it as a first button here. Do you remember how to do it? Right click somewhere here. Left click on customize. This is the active bar up here. We need to find the command down here. Left click on all, left click here and write clear. Hover cursor over this clear filter, press left button, hold it down, drag this command and drop it here as the first button on the active bar. Release the left button, close. See, now in this active bar, the very first button is the clear command. Perfect. We don't need this split view anymore because all the components, they are placed on the PCB. So what you can do, just hover cursor over this tab with the PCB name, press left button, hold it down, and drag it somewhere here into this first half of the window. Release the left button. We would like to see this PCB from the bottom view. So left click on this LS button, left click on bottom view. This is much better. It's not so confusing. We only see the bottom layers. We would like to adjust the shape of this polygon. So hover cursor over this polygon, left click to select it. Now hover cursor over this edge of the polygon, wait until the cursor shape will change like this. Press the left button, hold it down and move it. Release the left button. To refresh or to redraw this polygon, just right click, select polygon actions, and you can use Repur selected or you can use Repur all. So left click on Repur all. Left click on this interactive routing button. Left click on this pin. left click, 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 right click. Here is an error. See this green color? It means this track is very close to this polygon, so we need to refresh the polygon again. And you can do it also through menu. Just left click on tools, select polygon pores, and left click on repur all. Watch this green color here, okay? It will disappear. Watch this corner. The shape will be a little bit different. So left click on repur all. Perfect. Hover cursor over this R2 designator, press left button, hold it down and move it like this. Hover cursor over this D2 designator, press left button, hold it down, and it's picking up the connector, so press escape. Left click on all objects, left click on text. Hover cursor over D2 reference designator, press left button, hold it down, and move it like this. Release the left button, and don't forget a left click on all objects. To be able to generate professional manufacturing documentation, we need to create two more layers: assembly drawing top and assembly drawing bottom layer. We have already done some work on this assembly drawing layer. Do you remember? When we created footprints, we also created assembly drawing layer, and we used, do you remember what layer for this? Mechanical layer number 29. So let's have a look what is on this layer right now. Left click on this color, left click here, and left click again to disable all the layers, and just enable mechanical 29 layer, left click here. This is not exactly what we would like to have, because at this moment all the components are only on one layer. These components, they are placed on the top of our PCB, and these two, they are placed on the bottom side of our PCB. So the question is how to create a top and also bottom assembly drawing. You need to use a feature which is called layer pairs. Hover cursor somewhere in this area. Now right click and left click on add component layer pair. Here we are going to specify layer pair, and when you specify a layer pair, it means this one layer, which is here, mechanical 29 layer, is going to be split between two layers, and depends where exactly the components are placed, then the layers will be adjusted. So all the components which will be placed on top side of our PCB, they will be using our original mechanical layer number 29, and all the components which we will place on the bottom, they will be using different layer. You can use any free layer. I'm going to use let's say mechanical layer number 30. Press OK to create this layer pair. Nothing happened. All the information is only on one layer, mechanical layer number 29. See? When you make these changes, when you create this layer pair, you need to update all the footprints which are in your PCB. So we need to go into our library, left click on projects. We need to go into footprint library, double click on let PCB lib. Left click on PCB library tab. Now right click somewhere here in this space, and left click on update PCB with all. So when you use this command, if you make any changes in this PCB footprint library, they will be transferred into your PCB. So we would like to refresh all our footprints in our PCB. So we are going to use this update PCB with all. Left click, check all these checkboxes, left click on OK, and let's have a look on our PCB. Left click on this PCB tab, and ta-da! Yeah, left click on view configuration, disable the mechanical 29 layer, make it invisible, left click. Now the components which are placed on the bottom side, they are on this mechanical layer number 30, and all the components which are on the top, they have the assembly drawing on this mechanical layer number 29. Perfect, that's exactly what we would like to have. Now, you know how to transfer the changes from the PCB library into PCB, but I'm going to give you a little bit more, little bit better example how this can be used. Let's say we find out that one of these footprints is not correct. We would like to make some changes in this diode footprint because we would like to mark where pin 1 or where cathode is located. We would like to add a circle into this footprint. So everything what we need to do is just go into our PCB library, left click on this tab with PCB library, left click on PCB library tab here, find the LED footprint, left click here, and we are going to add the circle. Change the units, left click down here, change it to millimeters, left click into empty space, press G on your keyboard, select 0.1 millimeter, left click, this is going to be our new grid, left click on mechanical 29 layer tab, press Shift S to go into single layer mode, move designator a little bit, press left button on your mouse, hold it down and move it. Left click on place, left click on full circle, left click somewhere here, 1, 2, left click, right click, go into properties panel, change the width to be, I don't know, 0.3 millimeter, press tab, change the radius to be 0.1, press tab. Left click to unselect everything. You can adjust the position of this text, press left button, hold it down, move it maybe a little bit closer, release the left button, press Shift S, and that's exactly what we would like to have. Don't forget to save the library. Right click on this component here in this panel and select this update PCB with LED footprint. Left click here. This is going to transfer these changes what we just made. It is going to transfer them into PCB. So left click here. OK. Left click on this tab with the PCB, and here is the change. Perfect. What we are going to do now, we are going to make it a little bit nicer. So first I'm going to hide these holes and the hole in the via. Left click here, left click on path holes to hide it, left click on via holes to hide it. Change the grid, make it a little bit smaller. At this moment we are using 0.5 millimeter. So left click into empty space, press G and select 0.1 millimeter, left click, and move these reference designators maybe like this. Press left button, hold it down, press spacebar to rotate, release the left button and move it like this. Go also on the bottom assembly drawing layer. So hide this one, left click here, and enable this one, left click. And when you are working with text on the bottom side, sometimes it's very useful to flip your board. So sometimes it's useful to see the board from the bottom view. And you can do it through this checkbox, which is here, just left click here. Now see, you can nicely read the text. Or you can do it through the menu. Left click on view and left click on this flip board. Press left button, hold it down, adjust position of D2, and left button, hold it down, press spacebar to rotate, and place it here. It is very useful to create also layer sets for assembly, drawing top and bottom. So very quickly, let's do it. Left click on this button to create new layer set. Left click here to call it assembly top. Left click to enable assembly drawing top layer. Left click, disable this one. Left click, enable board outline. And left click to save. Now left click to add new layer set. Left click, assembly bottom. Left click, and left click to save. I'm going to enable these path holes and via holes again. So left click here, left click on this LS button and double check the assembly top and assembly bottom layers. Perfect. Our PCB is completely finished. There is one more thing what I would like to show you in the schematic. So left click on this schematic tab and we are going to create a variant. In the variant, we are going to specify that we don't want to fit this LED and this resistor. These variants are then used when we will be generating documents for manufacturing, because you can very nicely show what components are not going to be fitted or what components you don't want to buy. They are not going to be included in BOM, bill of material. So this is how you create a variant. Left click on project, left click on variants, left click on this add variant button, and let's call it LED to not fitted. Left click on OK. And in this column, we are going to set what components are not going to be fitted for this variant. So we are not going to fit this LED D2. Left click here, left click on these three dots, and left click to select not fitted. Left click on OK. And we don't want to fit the R2 resistor. So left click here, left click on three dots, left click on not fitted, left click on OK, and left click on this OK button. Notice these two new items inside of these variants in the project tab. This is what we have just created. Double click on this LED to not fitted and left click on this LED tab down here. If you cannot see this tab, you need to compile your project. So you need to go here on the project, right click and left click compile PCB. Then you should see this tab here. Left click, and in this view you can see what components are not fitted for this LED to not fitted variant. If you like, you can adjust the format how this is shown, how these not fitted components are marked. Left click on project, left click on variants, left click on drawing style, uncheck use graphic, check use text, left click. You can put there, for example, NF, not fitted, and I usually use this kind of font, Arial, bold 12, left click on OK. Here are some settings for PCB. We will go back to this setting a little bit later. Left click on OK, left click on OK, and this is much nicer. You can fit and unfit components for this variant also in the schematic directly. You can use this button, left click here, and left click on the component which you would like to unfit, or you can just left click to fit it again. Right click to cancel the command, and if you would like to continue to edit the schematic, you need to go into this editor tab. In this view, you cannot make any changes in the schematic, okay? You always need to go on this editor tab. So don't forget, left click on editor tab. Let's go back into our PCB, and we are going to check 3D model of our board. So left click on this PCB tab, and to switch to 3D view, you can press the number 3 on your keyboard, or left click on view, and left click on 3D layout mode. Wow! Yeah, all this is created based on the footprints where we use these 3D models. Use exactly same commands to control this 3D view as when you work in the library. So press Shift, hold it down, press right button on your mouse, hold it down, you can rotate the view, or just press the right button on your mouse, you can pan the view, and use mouse wheel zoom in, zoom out. In this 3D view, you can also see the variants. So I'm going to have a look on the bottom side of our PCB. Press Shift, hold it down, press right button on my mouse, hold it down. And at this moment, see, these two components, they are not fitted. Because when I left click on the Projects tab, you can see we are in this variant let to not fitted. When I double click on these no variations, these components will be fitted. Not fitted, fitted. To go back into 2D view, just left click somewhere into this canvas and press number 2 on the keyboard. And now we are ready to learn how to generate output for manufacturing.